Hello, this is Minder Chen. I'm Professor of Management Information System at Martin V. Smith School of Business Economics, CSU, Channel Island. In this lecture, I'm going to demonstrate a grocery store data warehouse. It was implemented in Access, and you should be able to download a zipped version of this grocery data warehouse. Once you unzip it, it is really just an Access database file called Grocery 2003. You can double click and open it up. Once you open it up, you're going to see a list of tables that has been created for this data warehouse application. And the best way to look at the structure of this data warehouse, look at the relationship diagram. And as you can tell here that this is a star schema. We have the facts table, which stored some measures such as dollar sales, unit sales, dollar cost, and customer count. And we have 4 dimensions: promotion dimension, store dimension, time dimension, and product dimension. Time is the when dimension, product is the what dimension, store is where dimension. The promotion, probably we can consider that's kind of why dimension. And each of the dimension has its own primary key, and all the 4 primary key for all the dimensional table out there has been placed in the facts table, serving each one of them as a foreign key, so we can build up the link to identify additional data for each of the dimension. The 4 foreign key together form the primary key for the sales fact table. Let's just look at what's the content of this sales facts table may looks like. I'm going to open it up. Okay. And if you look at a detailed record, it can be very confusing and difficult to understand. But let's just try to calm down and read it. On a particular day, 1, we'll find out what is that first day is. Product number 1 through promotion 1, sold through store number 15, and we have sold 58 units of it, and the total sales dollar amount is $78.35, and the total cost for all those products is actually $81.90. So basically we were selling this product at loss. And totally there are 38 customers who has purchased this product 1 using promotion number 1 at store 15 on this day 1. So if you want to find out what is day 1, what day that is, just go to the time dimension, and you'll find out day 1 is October 1st, 1994. It's a Saturday, etc. It's belong to the 4th quarter of 1994. So that's day 1. Okay. If you're interested in find out store 15, you can just come here and store 15. It's right here. It's at Denver, Colorado. That's the store 15. Same thing for promotion. If you look at promotion number 1, it's a temporary promotion for blue ribbon discount. That's the promotion name. It's on the ad on the daily newspaper, etc. Okay, and the promotion beginning day, ending day, it's from October 1st to October 15th of 94. And even no promotion, we have an entry for just the customer may be buying this without any promotion. That's certainly quite common. So this is how you can kind of try to understand the data in the so-called sales facts table. If we go back to the store dimension table and try to look at its column, you'll find out there's quite a bit of column. So it's Y, as we call it, dimensional table tends to be wider than the facts table. But by comparison, if you go to the facts table, you find out the facts table only have just a few columns. Some foreign key together form the primary key and a few measure. So we'll come back to the store and look at its design. And one thing you may want to study is why we add a lot of attribute other than the basic information about the store, where it's located, who's the manager, telephone number, etc. We added quite a few attributes, such as this group. We have floor plan, we have photo processing type, whether there's a photo processing facility in the store, when there's a financial service provided through the store, and when it was first opened, when it was last remodeled, and the store square footage, grocery store footage, and frozen food square footage, area which carry frozen food, and area in terms of square footage carry meat. Because all those attributes may potentially affect the store's sales, and so those are the performance driver. So if you come back to look at the sales facts again, it's just very difficult to make sense out of this this facts table. And so how can we use this information for analytical processing? To do that, we pretty much need to generate some views out of this data warehouse. And there's already one view, but I'm going to create a new one. I'm going to say create. I'm going to create a query. So I do want the sales facts, and then I do want to analyze it based on products, based on store, based on time. And I can put the promotion, but I'm just leave it alone. I'm going to just close it. Okay. I'll arrange it, just rearrange a little bit so we can see a little bit better. Okay, what it's like a reduced star schema that we have. So first you want to identify the measure or select the measure that you may want to use. Dollar sales sounds good. Number of unit will be okay. Customer count. So you can select a few measures that you potentially may want to use. For a product, we can choose the attribute which we think may be relevant in analyzing the sales data. So there is a hierarchy which we will discuss in detail regarding the product's dimension, which is in this case is department, category, subcategory, and brand. You may want to just throw in the description, which is really the product names, into this. Okay. And by the way, when you choose a list of attributes which form a hierarchy, you don't really need to select it from top to bottom along the hierarchy. And it's when you really use it in your analysis, eventually you need to certainly know the order of the attribute in the hierarchy. For time, we can choose year, quarter, and maybe month. Okay, and eventually certainly you can choose date. Okay, why don't we choose date of the week? Okay, to kind of get an idea. And you can actually even select holiday flag to see whether that's a holiday, which will tell you if you sell a lot of stuff on a holiday, shouldn't be a surprise. For store, we're going to choose, in this case, we're going to choose state, county, and city. Okay, and you can actually go down to the particular store number if you wish. So I'm just double clicking those attributes while I'm talking. If you wish, you can actually add those performance driver like stored square footage, etc. That may affect the performance of your store. Okay, so once this is done, I'm going to just save it. I'll just call it sales. Let me just call it sales cube 1. Okay, I'm going to save it here. And once it's done, save the database. You can minimize it. How can we view the query? Certainly you can, let me come back again. I can run the query that I just formulated, but the result would be very much like the let's see what happened. Okay, in this case, let me close a few table. I couldn't run the query because I have some of the table open, which blocked me from running the query. If you run the query, it's a little bit better than the facts table. So you kind of would know that I sold this much, this many unit to this many customer. It's lasagna, and it's a cold gourmet frozen food in the food category under the grocery department, 1994 on the fourth quarter. The month, unfortunately, it's not coded as January to December. It's a kind of a identifier. It's sold on Saturday in Colorado, Denver, and city is Denver. And okay, it's a Denver County at the city of Denver. So so it's a little bit more readable, but it's still difficult to make sense out of the data. That's where Excel may come in to help us. I already got Excel here, and so I'm going to just get a new Excel workbook in this case. So I'm going to just get a new workbook, and then I'm going to bring that query result in here to create a pivot table, and I can directly link to that database. You need to have necessary credential in order to talk to the database in your Excel. Mine is here, and ask for username, password, etc. Okay, so I'm going to choose the sales cube 1. I'm going to say OK to bring the data into this worksheet. Okay, so it's pivot table. I have to choose actually the attributes that I want to use to build up this pivot table. And dollar sales make a lot of sense. I'm going to choose it here, just to the value. This is the measure. So here, this $781,403.59 is the total sales of all the product, all the store, and throughout all the period that included in this query will be, and this is the grand total. But if you want to analyze, kind of break it down, one way we can do is we can choose, for instance, I'm going to choose. Do I have? Okay, I'm going to choose department. So this is the breakdown. Okay, which means in the grocery department, the household department, this is the breakdown of this total sales into grocery and household. So we find out the grocery part of the store generate more sales. We can go even further. Okay, this is where the hierarchy will come in. If you know the hierarchy, the next level I believe is category. So you drag the category. So you find out that under household we only have one category, which is supply. Under grocery we have drink and food. I can go further. For instance, I have a subcategory. Okay, so drink, there's only one subcategory, soft drink. For food, we have candy, frozen food, and salty snack. None of them are really healthy. Okay, so you can actually keep doing this by eventually go down to the individual product level. Okay, if you wish. We can add another dimensions to this pivot table. In this case, I'm going to go after the store dimension. For the store, once again, you want to go from the top level of the hierarchy, and one of them is the. Do I have it? I don't seems to have it. I thought I select the state, city, store, state. I don't have state, so I'm going to choose. Do I have county? Okay, state, county. Oh, store, state. It's right here. So that's the store state. So now I have the breakdown of the sales to down to individual state level. Okay, so this is sometimes called cross-tab report. For instance, let me contract this. For grocery sales in Arizona during this period of time, for all the grocery product, this is the amount. And this is the amount for drink in Arizona and the food in Arizona. Okay, if you want to say, hey, the food sales in Arizona is pretty good, but let's see what has been sold under the food item, then you can say, wow, it's frozen food that's selling really well. Not much of the candy or salty snack. Okay, and but here, California, okay, you find out that people tends to eat a lot of well, it's not really salty food sale is a little bit higher by comparison. Okay, and you may want to format this such that the data may looks a little bit easier for you to make the comparison. Okay, for instance, we can use currency or just number, 2 decimal place. Okay, so everything is in 2 decimal place. It's a little bit easier for us to kind of make a comparison here. And we can go further down the store hierarchy. In this case, to look at what we need to what we want to break down. Let me okay, so I'm getting this pivot table field list back. So if you want to go to the county level, store county, now you're getting down to the county level. For California, there's only 2 counties we operate, Los Angeles County and San Francisco County. I'm not even sure whether this is San Francisco County. But anyway, so that's a further breakdown. You can contract it, you can expand it to drill down. Okay, So if you look at here, we can certainly have this we can aggregate, okay, and we can drill down, we can roll up. Okay, so this can shed light in terms of our data set, help us to analyze it better. There's one more thing, one more dimension actually we can add to this pivot table is the time dimension. Time dimension can be useful in this case to be used as a report filter. So in this case, now the sales is actually 2 years of sales altogether. But if you choose just 94, that's the sales for 94. You can choose 95, year of 95. Okay, and you can choose both of them. Okay, and certainly you can go down to the quarter if you wish. So there are kind of so you can choose 94. Okay, for 94, unfortunately for our data, there's only the fourth quarter data. Okay, potentially we have first to fourth quarter, then you can choose a particular quarter's data in analyzing this pivot table. You can switch the row and column if you wish, and so you can pivot it. You can drill down, you can roll up. For instance, you can say, well, I don't want the county, so, and then you can choose county. Oops, in this case, county, you may want to drag it and put it here. Okay, so for the department, if you don't want it, I think we can just get it back and only look at the subcategory. Okay, or without it, and you can switch, you can pivot it, so you can have the stored or the state of the stored serve as a row, and use the product type based on department, category, subcategory, brand, and product name as the column dimension. That's called, so I can easily switch that. You can actually use the time dimension on the row or column if you wish. Let's just do a category here. Okay, so this actually gives us the information, view the information differently. So the pivot table function in Excel is a readily available front-end tool to help us to analyze the data in the data warehouse or in the data mart. Usually, conceptually, it's a cube that has been generated through a query. In this pivot table, we're allowed to see the multidimensional cube through a kind of 2x2 dimension with a filter, which is kind of the third dimension. And this would help us to find some insight from the data to help us to make better decisions. So this concludes our demo of studying the multidimensional data warehouse in Access in this case, and then formulate a query to extract the data, and then use Excel pivot table to visualize the data, to analyze the data. Thank you for watching. I'll see you next time.